Okay, well, I don't have too much for announcements today, so I'll go and just get those out of the way. I posted this in class announcements, but the attendance code for last week, I forgot to schedule, or I didn't schedule that properly. And so I went ahead and just omitted that attendance for last week's class, the one on Thursday. So it will be skipping a day, so it'll be just onto attendance code 9, and your TAs will distribute that tonight. And the meetup for St. Louis is happening on October 1st from 1 to 3:30. And we'll also have some people from the in-person class that started recently there, and they'll have just completed assignment 1 back in JavaScript. So as the senior class members, you can give them some great advice about what to do, what not to do, just overall course advice. And there will be coffee and maybe donuts. And that is all I have for tonight. I hope y'all have a great class, and let me know if you need anything.
Thanks, Colin. All right, put my screen back up. Okay, so tonight we are taking a brief break from Spring after just introducing it. We're going to just talk about some basic Java stuff that you'll need as we get deeper into Spring. So we'll talk about exceptions in Java and some of the IntelliJ tools that can help you with debugging when you run into problems. Okay, so classic format tonight. It's actually going to be a pretty short lecture, but I'm still going to do a break between the two chapters. So yeah, it would probably be about 20 minutes and then another 20 minutes, and then you guys can go to studio and have a great night doing all the things. Okay, so this is the same stuff that's been up for multiple classes now. Graded assignment 2 deadline got moved to Monday because of us having to switch the dates this week. And so your catch-up class is on Thursday. That will give you more time to get ready for that, but you'll have time during studio likely tonight as well, because the studio is also not very long. To work on to get all that wrapped up, spend time with your TAs, getting your questions answered, that sort of thing. All right, let's get into it. So let's talk about exceptions. The idea here is that you want to anticipate and handle errors that may happen. It's really more of a planning process than anything. So we'll talk about what exceptions are, and then how to handle existing exception types, and then also how you could create your own custom exception classes if you would like to. So some of this is going to sound really familiar, and it's because the same concepts are generally true in JavaScript, and we did go over a lot of this as it pertains to JavaScript, but there are some differences with Java. So in Java, because everything is compiled first, and a lot of things like type mismatches and syntax errors are actually caught during compiling, unlike JavaScript. But there still can be runtime exceptions, and there certainly can still be logic issues, right? So what we want to do here is, kind of look at some of these classic exceptions that you may encounter, and we'll talk about, how to handle them. So common ones, null pointer exception. This is very common if it just doesn't find an object because maybe your reference isn't quite right, or you passed something in that it wasn't expecting to have some additional like values in it that aren't there or something. Index out of bounds exception. That's what happens if you have an array of 10 things and you try to access an element at index 15 and it doesn't exist. And an arithmetic exception like dividing by 0, that's an example of something that would naturally throw that error. But if you have exceptions in your program, here's the important thing to understand. If they're not handled because you say, I understand that these things could happen and I want to make sure my code handles it, the code will just stop and not continue. Your application will break. So it's very, very important to anticipate what could happen. It might be just common cases. It might be edge cases. It might be situations where people just aren't, like another developer isn't using the code you wrote the way that it was intended to be used. And that could cause exceptions. So, it takes practice to learn how to anticipate those things, but our goal here tonight is to introduce the basics of this to you just enough that when you get into the real world, and if you are handling this sort of thing on your job, this will not be new to you. You'll still have more to learn, but we want to give you enough of a foundational understanding that you can start to implement it in some of the things you're coding as a student, but certainly have a good, launching pad, so to speak, when you are in the real world. Okay. So let's talk about handling exceptions. So you just want to plan for things that could come up. A good way to do that is with a try-catch block. This works the same way that it does in JavaScript. You can kind of catch an exception as it already is, like something that is going to be thrown by JavaScript that's built in. You can even deliberately throw an exception. I'm going to do examples of these for you because maybe Java doesn't naturally catch it, but it's something that you want to be handled if it comes about. And if you do that, use the throw keyword, and then you can just make it happen in line by creating an error object with a new keyword of whatever exception class you want. So if you look at this example I've got here, I mentioned earlier that an arithmetic exception was something that would naturally get thrown if something happens like dividing by 0, right? It turns out that if you try to take the square root of a negative number, Java doesn't throw an exception. It just gives you not a number. So what if you had someone, you're writing this thing and you want to say, normally you would just say, okay, just return the square root of this number, right? That's all there is to it. But if you want to make sure you can handle the possibility that a negative number might be passed in, and you don't want not a number to be a response because your assumption is that maybe the person using this just didn't realize that they were supposed to make sure it was positive before they passed it in, you can actually handle it with your code. So there's kind of two things going on here. One is that you would first, try checking to see if the number is in fact, greater or less than 0. And if so, we can throw an exception and give it our very own message. So we just force it to trigger this. And we can say, okay, I'm going to say it's an arithmetic exception. I'll use that class, which is a subclass of exception, and give it the message that I want it to have. And then I'll provide for what happens when it's caught. If it does get thrown, then here's what happens when it gets caught. Then we'll just print the stack trace of the error. Which is, just the message that comes out when something like this happens. And then, so that's the first part, is saying, I want the user, whoever's, doing this and using this method as part of their code, I want them to know that they did it, that they accidentally passed in a negative number. So I'm going to throw this exception just to throw up, that error message. But then I'm also going to make sure that the code does what I intended it to do. Oops, I'm sorry. Let me go back. So right here, I'm going to actually take the absolute value of n before I take the square root so that it makes sure that it's positive. So, this is a way, an approach that will, it's a very thoughtful approach of saying, it's a really simple, mathematical calculation. Take the square root of something, just return math.square root of n. But it's actually not that simple if you're trying to make sure that you're handling exceptions. And that's where you have to, be thoughtful about how you want to handle that to make sure your code will work as it was intended to. Let's go over, let's see, I've got a couple of things that we can do to practice this. So the first one is to handle, we're going to do, I've got this print element method that I've written that down here that will actually just take an array and take an index and print the element that's in that array. Now, would you normally have a method for this? No, but I'm trying to keep things simple so we can just focus on the exceptions. So we would want to say, what happens if someone was to pass in an index in a case like this, and it actually, there is no element, and it's going to throw an array index out of bounds exception. We need to handle it if that happens, right? So I've got this, array of strings that has numbers as text, 0, 1, 2, 3, 4, just as sample data, just to prove the point. And then I'm saying print element, I pass in the array, numbers as text, and then I say I want the index 7. Well, you can see pretty clearly there is no index 7. The highest index is 4, right? So I can run this. Let me run it from here. And we get, it looks like I already had it up. There we go. We have this, exception automatically thrown by Java. Now I haven't thrown anything. Java threw it. But what it did was it stopped our code. It broke the application, because you'll notice we didn't get anything else that, the lines of code that come after that never made it. The application just finished and said, whoop, there's a problem. I have to stop. So this is why we need to handle our exceptions. So let's come down here to print element, and we're going to modify it so it can handle that exception. And we're just going to print whatever the default message is. We're not going to give it our own message or anything like that. So we'll keep it pretty simple. So we'll do, first of all, a try catch block. That's step number 1. Try and see if it'll work. But if it does throw an exception, then do something different. But more importantly, try catch prevents the program from breaking, and it'll allow the application to continue running even if we catch an exception. So we'll try doing this. I'm just going to move, this code up into the try block and say, let's try that out and see if it throws an error or not. And if it does, then I'm going to say I want an array index out of bounds exception to be caught. I'm going to call it E. That's kind of common standard you'll see for people to just use E as a way of representing the error object. That automatically you can capture it right here in the catch block and do things with it. And then I'll just say, okay, I'm just gonna console.log. I've been working on something in JavaScript, so forgive me if I do a couple console logs tonight. Okay, so we're gonna say print the e.getMessage. So this is just the getter that exists in the exception class that array index out of bounds exception inherits from. Okay, so e.getMessage, instead of retrieving the entire stack trace that we see down here, it's going to give us just this message at the end. So let's run this and see what happens. All right, so we see index 7 out of bounds for length 5. So it went ahead and gave us its built-in message, but customized with the specific values. It says, we've got a length of 5 here, but you tried to access an index that doesn't exist. And then we see it does continue. So we've no longer broken our application because we handled the exception and allowed it to continue with the next lines here. Okay, so that's example number 1, where you're handling that out of bounds exception. Let's do one that was the one on the slide where we're doing the square root, where JavaScript does not catch it. You'll notice here where it says the square root is of -5 is not a number. We don't want that to happen. We want it to actually give us a real number. But Java doesn't deal in imaginary numbers, so this is what it does instead. So let's come back up here, and we don't need to change anything about this. We need to go to this method get square root and make some changes here. So we're going to modify it so that we can throw an arithmetic exception on purpose if n is less than 0. And then we can handle it once it's caught. So I'm going to do a try catch block again here. I'm just going to set it up. So at minimum, this is what you want to be able to have. And then we'll just do our logic here that says, here's what we want to determine if we want to throw this error or not. And in this case, we just want to say if n is less than 0, if somebody passes in a negative number, then throw a new arithmetic exception, and then we can give it our own message. So I'm going to say, warning, cannot take square root of number, negative number, Want to be very specific here. And then I'll just, tack on the end there so we can print that as part of the message. Okay. So that's how we decide whether this is going to get thrown or not, is by that logic. And then we say here, sorry, wrong one. Let me just, okay, arithmetic, there we go. If we get this error object back, if it's caught, then here's what we want to do. We just want to print the stack trace and then let it move on. And so it can still return. But you remember when I was showing you the slide, I said, there's one more thing we want to do here. And that's make sure that not only do we have a warning for the developer who's seeing this behind the scenes, but also make sure that it actually gives the value of the positive value that they passed in. So we can just do that by, instead of saying n, we can say math.abs for absolute value, and pass in the absolute value of n there, so that the square root is actually going to be a real number. So now when we rerun this, we're not going to see the square root of -5 is not a number. We're going to see a stack trace, and we're also going to see the actual square root of 5 instead of -5. Let's do it. There you go. So the square root of -5 is 2.236, et cetera, et cetera. Okay. So we're actually, making sure our code is used the way we intended it to be used, even if somebody accidentally submits, passes in a negative number. And we also are giving them a warning, but we're not breaking our code. And we can prove that by putting another line of code here. So I could just say, the code continues to prove it. So let's run it again. There you go, the code continues. So this is something that came up the last time I taught this. Why would the stack trace print below these two lines if we're actually catching it here before we return this value that comes back here, right? And the answer to that is that these things run asynchronously. You've got two different things going on at the same time. You've got your actual code running here, and then in the background, it's also processing these error objects and their messages. So sometimes you're going to see these come out in weird places, but they will come out one way or another when you throw them and handle them. Okay, so before we talk about custom exceptions, I'm going to go ahead and stop and take questions now in case anybody's got questions before we move on to the next thing. Anybody got questions? No? Okay. All right, so let's, oh, now we have a question. Okay, Yumi?
Sorry, I just wanted to ask if you'd be able to zoom in a bit on your IntelliJ. It's a little hard to read.
Yeah, I changed the font sizes, but they're, I might need to adjust it again to make it even. It's difficult. Yeah, I've got a 27-inch screen, so I know for some of you guys that translates to it being pretty small.
Yeah.
Okay.
This is looking easier, so thank you.
Okay. Yeah. Okay. Yeah. I'll change it in the settings again before the next class and see if that makes a difference. Okay. Down here, I can't really do a whole lot about it because every time you rerun your program, it resets. We'll see what I can do. Okay. So let's talk about custom exceptions. You can create your own exception class and make it as specific as you want to make it. So you can use class inheritance to just use the base class exception and then just create something that inherits from that. Pass your message to the constructor with that super keyword because that's really all it requires. And then you can be really creative with however you want to build it. Like this is a very, very silly example. But let's say you have some sort of thing where you need to make sure that the word has a real vowel, like a standard vowel, A through E. For some reason, this is important to your application. You need to, have some way to catch that, right? And so we'll call this the no vowel exception. We're going to extend exception so that it inherits all of its methods and fields. And then just use that super keyword to pass the message that we want up to that class constructor that's inheriting from. And you'll notice that you know, I got to decide here, hey, I just want this to take a string word, and then I can use that to create my message however I want as part of the message. So you don't necessarily have to make it where it takes a full message. You can customize it this way too, and actually, you know, give it other things, and then make that part of your message. So let's code this and see how it works. So I've got another little thing here. We've got this an array of strings called story types. And it has 4 values, epic, fable, myth, and folktale. One of these does not belong. And so immediately we can see we've got something that we want to catch. Oh, hey, we're not going to be able to use that word because it has a Y. Don't ask me why. I don't know sometimes when I make up these examples, but let's just roll with it. And so we got to do something about this. And I do have a helper method down here that is called has a vowel, and it's going to give us a way to check whether something has a vowel or not, and just return a Boolean, you know, true or false, right? So what I want to do, and I'm not going to make another method to do this, to call. I'm just going to do it right here. I'm just going to handle it right here. And I'm just going to say, you know, for string story type of story types, this is a for each loop. And that way we can look at one word at a time. We'll do a try catch. So I'm going to set that up. And the question is, you know, what do we put in the parentheses there? What type of error are we watching for to catch? And so we're going to need to have some sort of logic here to say we need to check and see if it has a vowel or not, and if so, we can throw, you know, this thing. So I can sort of start to set that up, even though we haven't defined it yet. I can say, you know, if has a vowel and give it story type. Then we'll, you know, throw the new, I should say just custom, throw custom exception. There we go. And then otherwise, we will print the word, which was our goal all along, was just to print these one at a time. That's, you know, I'm sorry, I'm sticking to it. Okay. So, but if we catch it, then we're going to want to, you know, print the stack trace. So we've got a little work to do before we can do this, because we need to define what this exception is going to look like. So I'm going to come over here to my class 9 package, and I'm going to create a new class and call it no vowel exception. And it looks like a normal Java class. And I'm going to extend the exception class. And as soon as I do that, you'll notice my fancy little icons changed it to this lightning bolt, because it recognized, hey, we're now defining an exception class. And, you know, so we're going to mark that out a little differently. But all I really have to do here, this is not that much work. I just set up the constructor and say, you know, no vowel exception. And remember, I said I wanted it to accept just a word, and then I can build the string inside for the message. So I'm just going to call super, call the constructor of exception, and say, warning, the word, I want a single quote and then a quote. There we go. Plus word plus has no standard vowels. All right. So we can use the word to plug it in as part of the sentence, but make our own little custom message here. And then just take advantage of everything exception has to offer to handle the rest of it. We can, you know, print the stack trace. We can print the message. We can do whatever we want. But we have our own custom thing now. So let me come back over to main, and here is where we can say, you know, throw new no vowel exception from class 9 package. And we will give it the word. So I'll just give it story type. And then here we can, and by the way, right then when it pops this up, if you look at it, it says unhandled exception. It's warning you, hey, you threw something, but you haven't handled it yet. And I'm like, yes, I know, but I'm not done coding yet. Give me a second, right? So now we're going to catch it. catch no vowel exception E. Okay, so now we have an error object of the no vowel exception class, and we can just say E dot print stack trace, which it inherits from exception. And we're good. Okay, so let's run this now and let it loop through each one of these and see what happens on each loop. Okay, so we get epic, fable, and then folktale, and we don't see myth, but instead we see this stack trace where it says, warning, the word myth has no standard vowels. So that worked exactly the way that we wanted it to. And again, I know this is a very silly example, but hopefully it was just simple enough just to show you it's not hard to create a custom exception. And in the case where you might need something that Java is just not going to handle by default. All right, does anybody have any questions about any of that I just did? Devin.
I'm sorry if this is a little bit off topic. I was interested in the initial vowel checker because when I would think of like a method to like sound out, it's like, okay, I'm gonna have a word where I check the vowels. I think I would have did my mind. I was interested where you came to that, where it's like you're checking the letters if it's in the vowels rather than checking if a vowel is inside of the word. Sorry if that's a bit of a word salad. I was interested how you came to that conclusion, or if it's just something that immediately came to you.
You talking about just my choice to do the logic this way?
Yeah.
Yeah, because this is the most straightforward way to actually define what a valid vowel is to just give a string and see if it contains that letter, rather than doing the opposite, like checking consonants or something. Like, I mean, it's much easier to compare the letter against all the possible perfectly good letters than to try to do the opposite.
Gotcha. Thanks.
Is that what you're asking?
Yeah.
Yeah. Yeah, this is something that a lot of students run up against. You guys remember Scrabble score from Unit 1? That was your graded assignment too. This kind of logic is the same kind of thing where it's like there's lots of different ways to do it. But sometimes stuff like this is just, the easiest way to handle it. Yeah. Okay, Abdul Razik?
Hi, I just confused where you use single quote and then double quote again.
Oh, yes, in the class, let me go back to that. Because I wanted the word itself to be in single quotes in the error message. So if we come down here, let me see if I can blow this up for you. You see how it has single quotes around it?
Yes.
Yeah, I wanted the message to actually read out that way. So I put the single quotes just inside the double quotes on either side of it that way.
Okay.
Yeah, it's just a formatting thing.
All right, thanks.
Yeah. Okay, let's go ahead and take our 5-minute break. It's a little earlier than usual, but that's okay. And when we come back, we're going to talk about Gradle and debugging in IntelliJ. All right, welcome back. Let's talk about IntelliJ tools for debugging. Look at Gradle a little bit closer. This is something that's included in your chapter, and I wanted to make sure to mention it as well. And then we'll get into the debugging process. Okay, so Gradle, we've talked about Gradle a little bit and just basically said it's for building, but we didn't really get into the details of that. So Gradle is a build automation tool to create an application. That's just a fancy way of saying that it will put together everything you need to make your application and kind of handle a lot of different things for you automatically so that you don't have to build it from scratch, because that would be a nightmare. So some of the things it does is to integrate frameworks and dependencies, run tests, compile and package the code. It provides a consistent process, and it also works with multiple languages and platforms, and works in different IDEs, not just IntelliJ, but Eclipse and others. It is reportedly nearly twice as fast as Maven. It has some improvements on Maven, and it's very easy to maintain with the build.gradle file, which we're going to look at next. So this file, I think I showed it to you briefly last time, because we were just looking at that source compatibility value there, where we're saying this is the version of Java that we want to use, and we're comparing it against the settings in some other places. But there's a lot going on here, so let's talk about it. What this file is a script that outlines the build process, and it's just has essentially the primary configuration for just about everything. So it says when we're building or rebuilding the application, we want to make sure that all of these different things are integrated. So If you have any plugins, those are, up there at the top. If you have any repositories, like right here where the source code is for the dependencies, and in this case, Maven Central is where all these are in this example. The dependencies themselves are listed here. And as we learn more throughout this unit, you're going to find this list of dependencies is going to grow and grow because you're going to introduce more and more different libraries and things. And then additional configurations, which aren't really shown here. And tasks, like if you're going to run tests or do other things that you might want to include. And then, Spring Boot actually creates this file for you. So not only does the file lay out all of a bunch of things it's going to do for you, Spring Boot creates the file. You don't have to write it from scratch. So it makes it very, very easy. And then you only really come in here to edit it if you need to, if you're going to add dependencies after the fact or things like that. Okay, so that's pretty much Gradle. And one of the other things I really like about it is that it's written with Groovy. It's kind of based on Groovy, which is much easier to read than XML, which is what Maven uses in its pom.xml file. So yeah, that's another point for Gradle. Okay, so let's talk about debugging. There are better ways to find errors than to just put logs in the console, believe it or not. So your code might compile just fine. It might build, it might compile just fine, but that doesn't mean there aren't still errors. There can be runtime errors, and there especially can be logic errors. And you're just not going to find them out until the code starts running. So IntelliJ has a built-in debugger that makes it super simple to see exactly what's happening line by line as you're executing the code and where the values are changing, so that you can narrow down where your logic has gone wrong or otherwise what's happening. So you can set breakpoints. Those are the dots you see there on the left. Like this here is a breakpoint that you've set. This is a breakpoint, the breakpoint that you're currently on. It looks like this as you're moving through it. And you run it in debug mode. So if you look here, like up on this top bar, it's that little thing that looks like a bug that's right next to the run button. That just means run it, but run it in debug mode. So it's just an alternate way of running your program. And it still runs it otherwise the way that it normally would. But then it'll stop at those breakpoints. And it'll allow you to move through the code one line at a time, or jump around depending on which buttons you use. And you can inspect the value of the data at each point. And you can kind of see already from this screenshot here that it's showing me over here, what these values are, even right in the code, which may or may not happen for you depending on what your extensions are and things and what you have enabled in your settings. But you don't have to depend on that. There's other places to see the values. We're going to get into that in just a second. Let's talk about the different ways you can move through the code so that you know how to control it. And then we'll talk about what you can see while you're doing that. So to move through the code, there are several buttons. These are the 4 that you probably will use the most. The first one is step over, which does not mean skip. It actually means execute the line that I'm currently on and move to the next one. So an important thing to remember is that when you are, and I'm actually going to go back to the previous slide, when you are on a line, like this shows down here, the green line, it has not yet executed that code. You're on the line, but until you hit step over or something else that makes it move forward, it has not yet executed. So let's come back over to here. So step over will just go to the next line that would logically execute, which may be in that file. It might be inside of a method in another file, but it will go to the next line. Step in actually allows you to jump specifically into a method or something like that to go in and inspect that line by line rather than just seeing it jump to the result of having run that method. So it depends on how much you want to drill down into your methods and things. Okay, and then stepping out allows you to return back to where you were where the method had been called. And then this run to cursor doesn't probably mean anything to you. What it actually means is that it will kind of fast forward until the next breakpoint. So if you've set multiple breakpoints, and let's say there's a couple hundred lines of code between one breakpoint and another, you do not want to sit there and be hitting step over line by line 200 times, right? You'd rather just fast forward. So that's what that button allows you to do, is to just jump to the next breakpoint, because you probably thought about it ahead of time and you know exactly the different points where you want to go. Okay, so those are the buttons to help you control. So here's what you do with them to make them useful for you. In this debug panel down at the bottom, once you have started running something in debug mode, you'll see this pop up at the bottom. You'll see a list of the available data and their values. And keep in mind, again, that's before the current highlighted line has been executed. So that line, when it is executed, may change those values, but it hasn't yet. So whatever you see here is prior to execution. And then you can also enter custom expressions here called watch expressions to evaluate. And if you just hit enter, it'll like give you a result. But if you actually like set it as something to watch, it'll show you the variable name or whatever that you want to watch. And I'll demonstrate this for you. And you can kind of keep an eye on these things. And it's so much better than having to go and plug in a bunch of logs, you know, for the console everywhere. Because then they're limited by exactly where you put them, and you can't just see the value changing over time. So once you get accustomed to this, and this is what your studio tonight is going to help you do, is get used to this. It's a great tool, and you'll probably really like it to help you narrow down and get to the problems in your code faster than you would by any method you've learned so far. There's one more way you can set breakpoints, and I'm going to go ahead and talk about it, and then we'll actually get into it. One more way you can set breakpoints, you can actually set a breakpoint and not just say, I want you to stop here, but I want you to stop here if this is true, and give it a conditional expression to evaluate. And so if you want to do that, you can set the breakpoint and then just right click on it and say, I want to make it conditional, and put that in. And then it'll skip it unless that expression evaluates to true, and then it'll stop. So it gives you a little bit more, a better way to kind of nuance, you know, your search, because you know you might have a loop and there might be something you're interested in seeing, but only under certain circumstances, and so you don't want to have to stop on every single loop. So let's go take a look at how this works. We're going to come back over here to main. Let's see, let me start by just placing some breakpoints at some different spots here. Let's see, let's do it here. And then I'm also going to do it here. And then we'll probably go down, and yeah, we're going to finish up by doing some stuff here. Let's just start with the broad things that are right here in the main method. So instead of running the class, I'm going to come over here and debug. And if you haven't done that yet, and you don't have the configuration for either running it or debugging it up here, you can debug it the same way. It's actually right here on this menu at the main method. You can just run debug, and then it'll be up here for you. Okay, so you see we have landed on the first line. And at the first breakpoint, I mean, and we are here, and you can see that it's just kind of, the only thing it's got available to us right now is it knows about numbers as text, so it's got that there. And we're like, you know, stuck here, but we don't really have anything to show for it. And there's no variable names, so this is not going to be super useful. But I just wanted to show you what it looks like to move through several things. So we can do that. Now, if you go over to the console here, and you can switch to the console right here, you can see that it printed the result of the first thing here when it threw that exception for the out of bounds error. And it is showing you, you know, this value for numbers as text right here in line. So you've got that information. So let's say we wanted to step forward. So I'm going to step past that, and you know, we can see that it executed the next line. The square root of 16 is 4. But we're on this one, and we haven't executed it yet. So I'm going to step again, and now it's executed it through our custom, well, it wasn't a custom exception, but we customized the exception to have a custom message. And it threw that and then gave us an answer we can live with, even though it was negative. So we can, continue moving forward. And now we see the code continues. Okay, so now we're going to get into this loop. And if I step forward, we're going to see this, just one at a time. And what if I was to go right now over into the debugger and go here and say, I want to watch this value story type. I can plug that in and say, I want to add this to the watches. And look what it says, story type, cannot find local variable story type. Now, why would that be? Anybody tell me?
Because you haven't gotten into the for loop yet.
Exactly, because story type is established. It's declared right here as part of the, setting up this mechanism, but we haven't executed that code yet. So this is something to be thoughtful about, is if you want to follow the value of something, you have to make sure it exists yet. Otherwise, you're just going to get something like this. So as soon as I step forward, we're going to see it has a value, because now we're inside the loop and this is executed. And we see that the value is currently epic. It's telling us we're moving through story types with all these different values, and story type is currently epic. So we can go through and step by step and notice that it skips straight to here because this did not return true. So we're going to print it. And of course, as soon as we get past this line, there's nothing in the console now. But as soon as I step again, we see epic show up in the console. And of course, it skipped the catch block because there was no error. So we could do this again and go through it and say, okay, now story type is fable. We're going to go through. And then we'll get to, myth. And now story type is myth. And we see that it does, in fact, throw this exception because it doesn't have a traditional vowel. And so it's going to follow a different path. So from here, it's going to skip the else block, and it's going to come down to the catch and go to the stack trace. So you're able to really very clearly evaluate exactly what the logical, flow is, this control flow of what your current logic does. And if it does something you're not expecting, then that's going to help you narrow down, hey, what did I do wrong? This is going to be useful, but what I would like to show you is what if we wanted to have some that not have to go through every single loop and do that conditional breakpoint, right? So I'm going to stop it, and I'm going to take this breakpoint off, and I'm just going to put one right here and say I want to stop here and do it only if. So I'm going to right click here and say the condition is going to be if story type equals, and remember we're doing string comparison here, so we use the equals method. And if I say if that equals myth, because I know my test data and I know exactly what's going to trip it. So we'll say done. And let me do one more thing. Let's purposefully break this so that we can see, kind of follow this of like, how are we going to evaluate this, right? So I'm going to put a not in here to break my logic, and it's going to do the opposite of what I expect it to do, and return the wrong value. So, but I'm only going to stop if it's at myth, and then we're going to follow it from there and see what happens. So let's run it in debug mode. All right, so we're here. And I still have a breakpoints I forgot about. Let me take that one off, and then I'll rerun it. There we go. Okay, so we're stopping here. Story type is equal to myth. Now we're going to watch it step by step and say, okay, what's going wrong here? And we see that it jumps to printing, and so we're like, oh, well, the problem clearly has to be here. So let's do this again, and let me actually step into that. And picture this, you've got a massive code base, and you do not want to have to go over here and go through the file tree to try to find the right file that has the thing you're looking for. So this is why stepping into something is so helpful. So I'm going to use this yellow down arrow button right here and say, please step into that method so that I can check it line by line and see what's happening. And now we'll say, okay, has vowels is about to be set to false. We'll go to the next line. And we're going to go, letter by letter here. So I might say here, I also want to follow letter. So I'm going to add that. I can't find it yet because we're still, before the loop is executed, but we're about to. So let's go in. And it says, okay, for letter M, has vowels false. So far, so good. Oh, wait, has vowels true. And so then we're like, well, what happened? I don't understand. And then upon closer inspection, we can say, wow, we did not expect that to return because we know that M is not a vowel, right? So our logic is clearly bad. We can fix this and rerun it. And this time, when we step down in and run it line by line, we see that it goes through M, it goes through Y, goes through T, goes through H, and it never does enter that has vowel equals true. And so it does return has vowels false. So it's working properly now. Okay. So I hope that's been a helpful demonstration of how that works. One more thing to point out, you'll notice that right now, while I'm down here inside this method, it says story type and letter. We don't know what those are because now we're in here. If I come back up and step out, now they exist again, or at least they do depending on where you are. Letter doesn't exist, but story type does. So keep that in mind too, that if you do actually add things to watch here, they're only going to be able to find values if you're currently in scope with the code, if that makes sense, especially when you're working with multiple files. Okay, does anybody have any questions about anything I just did? No questions? Okay, the best thing that I can recommend is that you just start pulling up the code and start just play with it, practice it. Set a few breakpoints, put in some watch values, try some conditional breakpoints. You're going to do all of that with Studio tonight. That's definitely going to give you practice, but I would encourage you to practice even more, go into some of the things that you're coding for your exercises coming up and things like that. And the first time you run into some sort of an error and you don't know what's going on, start adding some breakpoints and take advantage of this. Okay. So if no one has any questions, I will send you guys off. I told you it was going to be a quick lecture. So you have a catch-up class on Thursday, and then graded assignment 2 due on Monday. Monday, we will talk about time leaf. Time leaf is awesome. It's a great tool for being able to provide HTML templates where, different values of data can be plugged in. It's not super reactive like React is. But it does allow for updates and, has placeholders and things for data and easier ways to loop through things so you can reduce the amount of code, that sort of thing. So you're not having to hard code all of your HTML. So we'll be learning the basics of that, and then you'll be using that through the end of the unit for all of the views for your web applications that we're building in spring. Then we'll talk about models and model binding. That's going to be focused on classes that represent objects that might be stored in a database, which is where we're headed eventually. How to do validation with models, and enumerations, which is what enums is short for. So that's all good foundational stuff about, how to use the MVC pattern with a Spring Boot project. And you're going to continue learning all these basics, and then we're going to put it all together at the end for, some pretty neat projects. All right, so for Studio tonight, this is chapter 12. You are going to return to your class 7 Studio, the one with CD and DVD, that's in the interfaces/studio folder in your WebDev projects repo. However, if you haven't already seen my announcement and class announcements, you need to read that because the debugging branch probably does not exist yet in your local version where you forked that repo, because they added it later. And so I have instructions in Slack for exactly how to create that upstream link to the original launch code repo that you forked from and be able to pull in their new branches, and then you'll be able to check it out from there. So you're going to need to do that and to get to this debugging branch. So make sure you check that out that I posted earlier today in class announcements. Okay, so then just follow the instructions to practice using these debugging tools, using what they did, a very simple solution for that studio that completely ignores all of the bonus missions, which are what made it complicated. The original one is, fairly straightforward. It's just a handful of files. So you're just going to use a simple solution they're providing for you already in that debugging branch to practice this stuff. There are not any errors to find. Sometimes people are like, wait, aren't we supposed to be finding errors? There are in fact no errors, but you could put some in there intentionally. Mostly you just want to kind of go around and check values, do some of the things you watched me do today. But that's the value in this, is just getting practice, getting comfortable with these tools, because they're super useful. All right, so I will have the studio review up later tonight, as well as the lecture recording. And you guys, again, can use your extra time in studio tonight to work on graded assignment number 2, and have some time with your TAs where if you need questions, things like that. Just take advantage of having access to them during class time. All right, have a great night. I will see you in a week, since Colin and I will both be out Thursday, by the way, but your TAs will have it all under control. So you guys can do your catch-up class with the TAs. But I'll see you on Monday.